So here we have chapter 2, section 1. It is on relations and functions. I'm sorry about the last video. The last video was actually 2-2, direct variation. So let's go ahead and backtrack a little bit and talk about relations and functions. So in the math world, a relation is just a set of numbers that are grouped by usually ordered pair, what you're used to seeing from your geometry days over here. But we've also seen them before in mapping diagrams. Back in pre-algebra and algebra 1, when you started graphing lines, I'm sure your teacher had you make a table of values, also called a t-chart, and then of course we would graph those points. All four of these different ways are different ways to show a relation, how an x is related to a y. So this is just a real world example here where you could measure time versus distance. There's a whole bunch of different real world applications to relations of numbers. This is just a guy who decided to jump out of a perfectly good airplane for no specific reason, and we're plotting his points as time and then his distance from the ground. And if you think about this, there's actually an infinite number of points that we could pick, and that's why graphing just a set of numbers doesn't really show you the true picture of what a graph looks like. That you'd have to graph them all. Here we have the same thing that we've been talking about, different ways to show a relation of an x to a y, but I did put in a couple of keywords that you're going to have to know, and that is domain and range. If you haven't seen those before, they are just a different way to talk about your x values and your y values, also known as input values and output values. And domain goes with x values and input, range goes with y values and output. An easy way to remember this is when I give you an ordered pair, you can think of an ordered pair being called an ordered pair because they're in alphabetical order. So if you look at the other words here, domain and range, well, D comes before R, X comes before Y, so domain and X go together, range and Y. Input and output, well, I comes before O, input goes with X, output goes with Y. We'll talk about this f of x here in a little bit, but just another way to look at all of these guys. So while it's important to understand what a relation in math is, it's not that big a deal. However, this is a huge deal. Function, we're going to be talking about functions from here on out basically in Algebra 2 Honors. And you talk about it really for the rest of your math career, depending on how high you go in math. Everything is about functions. So it's real important that we understand what a function is. And a function is just a very special type of relation. And it's the type of relation that meets this criteria here. It consists of inputs called the domain and outputs called the range, but here's the rule. Each input determines exactly one output. You can also say, an easier way to say it is, for every x value, you can only have one y value. You can't have, like your set of numbers, if you have 3, 7 and 3, -9, well, if I told you to go to the x value of 3, what do you get out? If you have more than one answer, that's not a function. So it's real important that you get this concept down. So here we have a couple of mapping diagrams, and then we have a couple of listing out of ordered pairs. These are a couple of the ways that I could ask you, hey, is this relation a function? And in a mapping diagram, really all you have to do is the circle on the left will be your input value, and you can see the arrow, and it maps to an output. So if every input only has one arrow coming from it, then it's going to be a function. So in this first one, A, B, C, and D only have one arrow, but in the second one, A has 2 arrows. So B would not be a function. Look at C. We have 2 arrows going to the same output. That's okay. As long as I don't have 2 arrows coming from the same input, these would be, so A, C, and D are all functions, B is not. When I give you a list of numbers, the easiest way to tell if it's a function is forget about the y value. and just list out the domain, the x values, or just say them out loud, really. 1, 2, 3, 4. If you didn't repeat an x value, it's a function. So a is a function. B, 1, 1, well, I can stop there. I said 1 twice. And I will tell you that when you list out ordered pairs, you will never list the same point twice, because that's 1 point, and you just don't list it twice. So B is not a function. C is a function. It's telling you that it goes on for infinity, but it follows this rule. Whenever you go up a number or down a number, you just multiply that number by 3. You'll never have the same number twice. The third way I could ask you if something is a function is to give you a graph. And by looking at a graph, you should be able to tell if it's a function. Remember, for every x value, there can only be one y value. So if I were to give you an x value, that means you'd have to walk on the x-axis and find that point. All right. So if I said, hey, go on this circle, go to x equals 1. So let's say it's right there. And I said, hey, I want you to go get on the graph now. You have to climb the ladder to get on the graph. Well, you don't know if you have to go up or down, because I could go both ways. That means that one x value has 2 different y values. That's not a function. You learned about this back in Algebra 1, and they called it a test. They gave it a very specific name of a test, and it was called the vertical line test. If you can draw a vertical line through your graph and it touches the graph twice, it is not a function. Another thing I could ask you when I give you a graph, and I will on the test, is what's the domain and the range? So the domain, remember, is the x values, the input values. So it is the left to right numbers that we are looking at. We're trying to see how far left and how far right we go. When we give domain, we always start at the low end, and we would like to start at negative infinity, but this graph does not go that way, and we can tell that because it doesn't have an arrow. If this was an arrow right here, or this was an arrow down here, I know that I'm going towards the infinities, because this will never get to vertical, because then it wouldn't be a function. But anyways, so this domain is from -3 to +1, except for the fact that at -3, we would have to say -3 is less than x, because it has an open circle and it goes all the way to 1, but we close that circle, so we put less than or equal to. If you notice that kind of looks like our and. Well, it doesn't kind of look like, it is our and graphing that we did before. And then the range goes from -4, because now you go down, you're starting here at negative infinity, right? We've got negative infinity down here. We got positive infinity up here. And, well, this doesn't go all the way down to negative infinity, so you start moving up the graph, or up the y-axis, and say, oh, this is where I get on the graph, this is where I get off the graph. So my range is from -4 to 0. So in my class, I don't do a lot of graphing, especially by hand. We'll use some graphing utilities for sure, some Desmos or my graphing calculators. But we do write things out quite a bit in this next way. What you see here is called a function rule. You're explaining what the graph does. For example, in this first one right here, we're used to seeing this. This is just a line. But I hope that this is familiar over here. When I write it with an f of x, nothing changed except for the y turned into an f of x. This is called function notation. If it's written like this, you don't have to worry about, does it pass the vertical line test? Will the x ever repeat? If I write it in this form with this f of x, I'm telling you that this is a function. This side over here is a function, so you don't have to worry about it. But also, this f of x and this y are interchangeable, which means if I write it y equals, I'm telling you this is a function. So that's kind of nice to know. And then I could ask you to evaluate it at any x value by putting a number in there for x. This side over here doesn't mean anything. That doesn't mean I'm going to have to divide by 1, or if I were to write it a different way, let's say I was doing this same question and I did f of -2 equals 3 times -2 plus 2. Well, that's -6 plus 2. I get f of -2 equals -4. I don't have to divide both sides by -2. That's not, this side is not saying that it is -2 times f. This is just saying, hey, I used an input of -2 into my function and I got out -4. Okay, so don't go any further than this. This is the answer. A better way to actually write that answer is to write it like -2 comma -4, because that's an actual point on the graph that would be that the line would go through. So, and down here on the bottom, I could ask you questions like this. I could give you a few domain, and all you do is substitute them in to the function and get out a range, and you give me the answers like this over here. And last but not least, we have a word problem. If you remember, the first step to do a word problem is to define your variable. In word problems, sometimes it's nice to use context clues for your variables. I don't know how you write your t's, but I personally don't want too many people using t's, because they'll write their t like this. That is not a t, it looks like a plus sign. So if you're going to use a t, be a little fancy, give it a little tail, and make sure it looks like a t and not a plus sign. All right, because it's really good to use context clues in word problems, but if your variables look like a number or like a operation sign, then it's not going to be worth anything, because I'm not going to know what you're saying. All right, so tickets to a concert are available online for $35 each plus handling fee of $250. So no matter how many tickets you buy, you have to pay $250 handling fee. Not per ticket, just an overall fee. That is called a constant. So I'm going to add $250 to the end of this. But that $35, that's $35 per ticket. So that kind of gives me the idea that the tickets is the variable. So I'm going to define my variable as t equals number of tickets bought, and then I'm going to create my function. Well, I could use y equals, and I could have used an x, by the way. It doesn't matter what you use for your variable. But since this is a function, let's make it a function notation, and let's use some context clues. Well, I'm trying to figure out the cost. Well, I'm going to use a big C, and I'm going to use t as my variable, and now I can build my formula. Cost function of t equals 35 times t, $35 times the number of tickets, plus $2.50 handling, and there's your rule. And now you can answer any question. Well, they want me to evaluate the function for 4 tickets, so I take the 4, I put it in for the t, do a little bit of math, I get $142.50, write it out in a sentence. The cost of 4 tickets would be $142.50. And that does it for this lesson.